In this question we are asked to integrate e to the x minus 1 all squared. Now in core 3 we don't have a method for integrating that, so we're going to need to make it a bit easier, and to do that we're going to expand the bracket. So first things first, we're going to multiply out e to the x minus 1 all squared. So we write that as e to the x minus 1 times e to the x minus 1. Now, e to the x times e to the x is e to the x squared. Negative 1 times e to the x is obviously just minus e to the x. We end up with a couple of those. And then we have to be careful with the fact that negative 1 times negative 1 gives us a positive 1. Now, e to the x all squared, using our index rules, we can write that as just e to the 2x. We need to take off 2 e to the x's and add 1. Once we've written it in this form, it's much easier to integrate term by term. E to the 2x becomes a half e to the 2x. Be careful with that half there. Minus 2 e to the x stays as it is, and 1 becomes x when we integrate it. And of course, we mustn't forget our plus c. Once we've done that, we've got exactly what they were asking us to show. Now that we've done that, we can evaluate the integral here, e to the x minus 1 all squared, between 0 and log of 2. Now straight away we can use what we've already done, and we're going to substitute in log 2 and 0 as the limits. Here we don't have to include the plus c because we're using limits. So first of all, we get a half e to the 2 log 2 minus 2 lots of e log 2 plus log 2. And we need to subtract from that a half e to the 0 minus 2 e to the 0 plus 0. Now what we need to realise here is we can't cancel the e and the natural log in the first term there because the 2 is in the way. So we need to use a log law to move it up to the top. So we actually end up with e to the log 2 squared, which is the log of 4. So we end up with a half e to the log of 4 minus 2 e to the log of 2 plus log 2. And then obviously we need to realise that e to the 0 is 1. So all of those e to those zeros disappear. Now when we get to this stage here, we realise that exponentials and natural logs are inverses of each other, so they'll cancel each other out. And so we get a half times by 4 minus 2 times by 2 plus log 2. And then we're subtracting from that a half minus 2. And a half minus 2 is negative 1.5. So now all we need to do is sort out all of that. A half of 4 is 2. 2 times 2 is 4. And we will end up eventually with log 2 minus a half. Now in part 4 of this question, we are asked to use our answer in part 3 to calculate the region enclosed by the curve of g of x, the x-axis, and the line x equals 1. Now to understand what's happening here, we first need to realise what it is we've calculated in part 3. In part 3 we've been looking at y equals f of x, and we have found the area between the x-axis and the two limits, which were log 2 and 0. We're told earlier in the question that when x is log of 2, y is 1. So the area that we've actually found here is the red shaded area. And that was equal to log 2 minus a half. So when we come to this question, we want to use that fact to calculate the area enclosed by the curve y equals g of x, the x-axis, and the line x equals 1. But the most important fact that we know here, again from earlier in the question, is that g of x and f of x are inverses of each other. So they're reflections of each other in y equals x, which means that if we're looking at x equals 1, y must be log 2. And because they're inverses of each other, this red shaded area must be exactly the same as the red shaded area in the other diagram. It must be equal to log 2 minus a half, because it's essentially the same graph just reflected in y equals x. So to complete this question, we need to find the area of the green rectangle and take off the red shaded area, and that will give us the area under the curve between 0 and 1 on the x-axis. So the rectangle is just 1 times log 2, and then we need to take off log 2 minus a half, being careful to add those brackets to make sure our negatives work properly. Once we've done that, log 2 minus log 2 is nothing, and negative a half is just a half.